10.6, circles and arcs. All right, here are some definitions for circles that you should already be familiar with. So we're going to fly right through them. First one. We talked about the definition of a circle in class, so this should be familiar to you. A circle is a set of points that are equidistant from a given point called the center of a circle. The diameter is the segment that contains the center of the circle and has both endpoints on the circle. So basically it is the distance all the way across the circle through the center. The radius is a segment that has one endpoint at the center and the other endpoint is on the circle. Basically it is half of the diameter. The circumference is the distance around the circle. It's kind of like the perimeter of the circle. Congruent circles are circles with congruent radii. If they have congruent radii, then the two circles must be congruent to each other. And our last definition for this page, a central angle. A central angle is an angle whose vertex is the center of the circle. Moving on to the good part of this section, we're going to be talking a lot about the arc of a circle. An arc of a circle is basically just part of the circle. A semicircle is half of a circle. A minor arc is going to be smaller than a semicircle, so it has to be less than 180 degrees. And a major arc is going to be larger than a semicircle, so it must be greater than 180 degrees. Alright, let's talk about naming arcs. Naming arcs is rather simple. It just takes a little bit of getting used to. When you name an arc, if it's a minor arc, then you are going to name it. So a minor arc, you name it using two letters. For example, arc SP, you would name as SP with an arc over top. So it's kind of like line SP, but it's not a straight distance, it's an arc of a circle. For a major arc, for a major arc you have to name it using three letters. For example, if we wanted arc SRP, we can't simply name it SP. SP, if you only use two letters, refers to a minor arc, which would be the small arc, less than 180. You need three so that you know it's going to be a major arc. So if we wanted to name the major arc here, we would say arc SRP, still with the arc above it. Or you could name that exact same arc as SQP. As long as you have the S and P as your endpoints and one point vertex along the arc. Along that. Alright, so let's look at part A. What are the minor arcs for circle A? I did forget to mention back on the circles page, when you are annotating a circle, you use this fancy little circle notation. The dot in the middle represents the center, and you name it using the letter that represents the center. So this is circle A right here. So what are the minor arcs? Well, these are all the arcs that are less than 180 degrees, and there are several of them. We have arc SP, we have arc SQ, there's arc PQ, arc QR, and arc RS. Alright, and then what are the semicircles? The semicircle, we could say, is RSP. Or we could say that we have RQP. Okay, and the major arcs, again, there are several of them. You have to look at them. They start to overlap each other. We have arc PQS, arc PSQ, arc SPR, there's arc QRS, and then one more arc R, S, Q. All right, here is a key concept. When you're talking about the measure of an arc, you're basically referring to, well, how wide is the angle that corresponds to that arc? So arc RT would have a measure of 50 degrees because the corresponding central angle, that angle RST, is 50 degrees. However, if we were talking about arc RQT, this major arc here, we could simply take 360 degrees minus this minor arc to get 310 for the major arc TQR. All right, here's a new postulate, the arc addition postulate. This postulate is very similar to the segment addition postulate that we learned a long time ago. So basically the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So if you wanted to find the measure of arc ABC, if you knew the measures of arc AB and the measure of BC, we could simply add them together to get the measure of the entire arc. And just another key note, the adjacent arcs are just like adjacent angles. They're a little bit different, but they're pretty much the same thing. These are arcs that have exactly 1 point in common. So the two adjacent arcs would be beside each other, just like adjacent angles. Example 2, finding the measures of arcs. So what is the measure of each angle, of each arc in circle C? Okay, part A, what is the measure of arc PR? PR is this minor arc right here. It's already been labeled for us. The measure is equal to 77 degrees. Next, part B, what is the measure of RS? For RS, we don't have a measure. But if you notice, arc PRS would be a semicircle. So we could simply take 360 degrees,
180
subtract
degrees
this piece of
minus
arc that
the
we do
77,
know to get
and what we are left with is the measure of arc RS is equal to 103 degrees. Part C, let's find the measure of arc PRQ. For PRQ, we just found that arc RS was 103 degrees. And we know that PR is 77, RS is 103, and SQ is 28. So using the angle addition postulate, we know that, the arc addition postulate, we know that the measure of arc PRQ is equal to 208 degrees. For part D, we want to find the measure of arc PQR. For this arc, we don't really have enough information to add up all the arcs because we don't know the measure of arc PQ. But PQR, if you take 360 and you subtract arc PR, then we will find the measure of arc PQR. So 360 minus 77 will leave us with the measure of 283. Okay, for example 3, we're going to need a little bit of new vocabulary. The word we're going to learn is concentric circles. And these are circles that are coplanar, and they have the same center. So basically they are circles that are one on the side of the other, but they have to share that common center. Using the idea of concentric circles, let's try this example. A car has a circular turning radius of 16.1 feet. The distance between two front tires is 4.7 feet. How much farther does a tire on the outside of the circle travel than a tire on the inside? Okay, since we're talking about the distance around a circle, we are going to need the formula for circumference. Now there are two formulas you can use. The first one, you could say the circumference is equal to 2 pi r.
But essentially, if you know that know your radius and you multiply it by 2, that's the same thing as having the diameter. So you could also say that the circumference is equal to pi times the diameter. Either one is perfectly fine because they're equal to each other. So let's find the circumference of the inner, let's do the outer circle first. To find the circumference of the outer circle, we need to multiply 2 pi r. And we know that pi is equal to 3.14, or you could use the pi button on your calculator. And the radius of the larger circle is 16.1. Multiplying this out, you will get that the outer circle has a circumference of 101.108 feet. Similarly, let's find the circumference of the smaller circle. Circle is equal to 2 pi r. So 2 times 3.14. Now to find the radius of the smaller circle, we're going to need to do 16.1 minus the distance between the two wheels, which is 14.7. And that will leave us with 11.4 for the radius of the smaller circle. Plugging this into your calculator, you will get that the circumference of the inner circle is 71.592 feet. Now, in order to figure out how much more the outer tire travels than the inner tire, we just need to subtract. So we have 101.108 minus 71.592, which will equal approximately 29.5 feet. Okay, last theorem for the day, arc length. Arc length is a little bit different than the measure of an arc. The measure of the arc is talking about the number of degrees, but arc length is talking about the distance, and it relates to the circumference. So it's how much of the circumference is a particular arc. So in this theorem, arc length is the length of an arc of a circle, is the product of the ratio of the measure of the arc divided by 360 and the circumference of the arc. Basically what it's saying is if we wanted to find the arc length of arc AB, we could simply find the circumference of the circle and multiply it by whatever fraction of the circle we're looking at. So for example, if AB was 1/5 of the circle, just find the circumference of the circle, times it by 1/5, and you would find the arc length of AB. Alright, let's use that idea to find the length of each arc shown in red. For this problem, we want to leave our answers in terms of pi. So for the first circle, we're going to need to first figure out the circumference of the circle. Since they gave us the diameter, let's go ahead and use the formula circumference is equal to pi times diameter. Since the diameter is 16, the circumference must be 16 pi, leaving it in terms of pi. Now, we need to find the arc length of arc XY, which is 1/4 of the circle. So we could simply multiply this piece by 1/4. So 1/4 of 16 pi will leave you with 4 pi. So the arc length is 4 pi, and the unit here is inches. For the second problem, they give us the radius. So let's use that circumference is equal to 2 pi r. So we have 2 times pi times the radius, which is 15. So this is the same thing as 30 pi. Now, we do know that the arc we're looking for is 240 degrees. So you could either go ahead and do 30 pi times 240 out of 360, because that will tell us what fraction of the whole circle we're working with here for that arc length. Now, it's up to you if you want to go ahead and simplify this fraction, but if you're going to plug this into your calculator and go ahead and multiply it out, you really don't need to. But when you do multiply all this out and you simplify your final answer, you will get that the arc length of XPY is equal to 20 pi, and our unit is centimeters. All right, now it's your turn. Here are some practice problems. Practice number 1, that the little label got knocked off the page, so this is practice number 1. There are 3 parts, A, B, and C, and below is practice number 2. Here's practice number 3 and 4. Again, number 3 got knocked off. So pause here and try these problems. Make sure you bring these into class tomorrow and we'll go over them together. Have a great night.